All right, today guys we are going to talk about difference of squares. It's a sort of different kind of factoring, but we're going to be able to use our same rules, so let's go ahead and jump in. First, let's start with a FOIL problem. So I would like to FOIL this right here, so I need to remember the rules of FOILing. So first thing I'll do, remembering that it's basically a distribution, is distribute this x into the second parentheses. So I've got x times x, that'll give me x squared. I've got x times positive 5, that'll give me plus 5x. I've got negative 5 times x, that will give me minus 5x. And I've got negative 5 times positive 5, well 5 times 5 is 25. And negative times positive will give me minus 25. But remember, when I FOIL, I need to add the like terms in the middle. But when I do that here, I just end up with, well, I guess I could write minus 0x minus 25, but I don't really need to because this just simplifies to x squared minus 25. So that's kind of weird. I haven't given you a lot of FOIL problems where the middle term canceled out, but that's kind of what we're going to deal with today. So let's go ahead and jump in with a factoring problem. So I want us to factor x squared minus 36. So based off of our last one, see if you can think for a second and guess kind of what the factors maybe are. Well, before we just totally jump in, let me talk you through the process. So normally we have the middle term, and that helps us think through factors. But first, let's just jump in because we know that in these first two slots, it should be factors of this first term. So factors of x squared are just going to be, well, x and x. And now I need factors of negative 36. So I could maybe have something like 2 and 18 where one of them's negative. I could have 6 and 6 where one of the 6's would be negative. I could also have negative 36 and 1. So let's go ahead and put in our x and x here. And if it's kind of like our last FOILing problem we did, let's pick the same number, or the one that has the same number pair. So let's say I've got 6 and plus 6. Basically what you're trying to get here is factors that look the same, but their signs are different. And the reason that happens is because I have a difference of squares. So both of these numbers are a perfect square. And when I say that, I mean it's a number times itself. So that's numbers like 1, or 4, or 9, or 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, and 11 squared is 121, and 12 squared is 144. So anytime I have x squared or I have a number squared minus another number squared with no middle term, I'm thinking it's going to be this pattern of a difference of squares. Okay, and when I say that, it's basically, I'm figuring out the factors of this last number that are the same. So when if I were to FOIL this one back out like I did that top one, I would get nothing in the middle, or I'd get a 0 middle term. So let's try another one. And I'll kind of show you if I were to put 0 as the middle term. So let's go with x squared minus 100. Now let's say we didn't know about the difference of squared patterns. I could still write x squared minus 0x minus 100. Because this 0x doesn't really change the problem, because any number I put in there will be multiplied by 0 and essentially go away. So if I think about the factors this way, remember, in this first spot, factors of this first number, and in this last spot, factors of this last number. So I'm going to have x and x here, or factors of x squared. And I need factors of negative 100 that I'm going to give you a hint, add up to 0, or we have the difference of squares pattern. So I'm thinking like 10 and negative 10 maybe. So if I put plus 10 and minus 10 here, those would be my factors. And I can FOIL to check myself. So I'd have x times x, that's x squared. X times minus 10x. I'm sorry, minus 10, which would give me minus 10x. Then I do 10 times x. So that would be plus 10x. And then I'd have 10 times negative 10. Hey, look, my 10s will cancel out. I'll be left with x squared minus 100. So really, anytime you see a number that looks like one of these, and it's got something minus one of those numbers, so minus one of these numbers is a hint to me this is a difference of squares pattern. So this last one right here is a difference of squares. This is a squared number, and this is a squared number, or this could be 10 squared, like I showed you right there. I'm going to show you one more. My last one, we are going to say is 16x squared minus 9. Now this one looks initially different because there's a number in front. But notice that 16 and 9 were both on that list that you should have written down. So those are both perfect squares, or a number times itself, and so is x squared. So let's think through our parentheses again. I've got 16x squared and minus 9. Now notice when I have the 16 in front, it's positive. So I'm just going to have positive 4x and positive 4x. But with the negative 9, I'm going to have 3 and negative 3. So I'll put my factors in here, 4x and 4x, plus 3, minus 3. And again, I could FOIL to check myself, but I promise you with these factors right here, you're not going to get a middle term. Okay? So anytime you see a difference of squares, or something that has two perfect squares, so this list right here, and there's a subtraction sign in the middle, it only works when I've got the subtraction sign in the middle. That should be a hint to you that you have a difference of squares, and it will factor something like the ones we just did.